Okay, for the second part of the derivation process, we will find what is the change of weight between output layer to the hidden layer. So for this condition, we will determine delta Wij. So if you still remember, so the relation or the derivation of the delta Wjk and delta Wij will be the same. So we will just use the same notation here. Delta Wlj will be equal to negative n dE over dWij, since you are interested in terms of finding what is the change of weight with respect to this particular layer. So we will repeat almost the same process, only it will be a bit longer, since relation error is actually in the output layer, while delta Wij is actually in the hidden layer. So in order to achieve the output layer, so we will meet with the net j here, and then oj, net k, ok, and then we will reach with the error. So the same thing, our first aim is that we need to find what is the dE, the chain rule that able to find the relation between error and Wij. So for this case, we use the same concept, dE over dWij. In here, if you feedback the things, first thing first is that we will meet with the net j, since this is the hidden layer of j. So dE over d net j times d net j over dWij. So this is the first part. So d net j over dWij, we can settle up this thing by using this equation. So however, we don't have any direct relation from error to the net j. So the next part, we expand dE over d net j times the latter part. So dE over d net j, since for the oj layer, first you meet with the net j, later on the oj. So we expand the thing by using the dE over doj times doj over d net j. So this is actually the expansion for this part. So we times with respect to the latter part, this is d net j over dWij. So d net j dWij is total. dOg over d net j, you can find it from this equation. dE over dOj is still not the direct relation, so we need to expand this thing. So dE over dOj, so in here we have the net j, so we have the oj, so we meet the net k here. So dE over d net k times d net k over dOj, so this is the expansion of this part only, so times the latter part, which is the dOj over d net j times d net j over dWij. So d net k over dOj, you can find the relation in here. dE over d net k, we have actually already derived that part in here, which is we have the whole part of the dE dWjk. dE over d net k is the whole part of this equation without the oj. So we can utilize this thing in our final derivation later on. So for this part of the derivation, we are left with the four part of the partial derivation. This is first part, second part, third part, and then fourth part. So for the first part, which is the dE over d net k, we can take this part from this equation. So this is the dE over dwjk. So dE over dwjk from our previous equation, if we omit the final part, so if you recap back in terms of the chain rule derivation for this part, okay, dE over dwjk equal to dE over d net k. So dE over d net k times d net k over dwjk. So d net k over dwjk, if we omit that thing from the equation, we are left with dE over d net k. So d net k over wjk is actually our part 3. Part 3 is here. So if we omit this thing from our final equation, we can find the dE over d net k. So our dE over d net k is equal to this part, tk minus ok, negative 1 minus ok without the oj, since we omit the final part. So we are settled in terms of our first part of the derivation. So the next part is we move on to the second part of this thing. Second part means we want to find the d net k over doj. So net k okay, I just take this part a bit higher so that you can see here, okay, and here. So net k equal to the summation of j oj wjk plus bk. So d net k over doj is straight away the same thing that I have shown you previously, will be equal to wjk. So we are settled in terms of the second part of the equation. Next we move to the third part of the equation, doj over d net j. So oj equal to 1 over 1 plus minus e net j. So doj over d net j, so it will be almost the same derivation that we have done previously in here, if you still remember. So you just need to change the symbol here. So it will become 1 minus oj So we are settled in terms of the part 3. And then finally in part number 4, d net j over dwij. So net j equal to the summation of I oi wij plus bj. So this is almost the same with the derivation of our previous layer. So d net j over dwij will be equal to oi. So previously in the output layer wjk, it will be equal to oj. So we already define all the part from the partial fraction, from the chain rule derivation. So the next part is that we merge everything here. So I just put this section so that we can combine every equation, 1 2 3 4 here. Okay, So our dE over dWij equal to first part of equation is tk minus ok negative 1 minus ok times part 2 will be wjk times part 3 will be 1 minus oj, and then part 4 will becomes oi. So this is the dE over dWij. So since we are interested to find the delta Wij, delta Wij will be equal to the negative and dE over dWij. So negative n of the whole part here, tk minus ok negative 1 minus ok wjk 1 minus oj times oi. So since it is negative and then this is negative, so it will become the positive. So our final equation will be tk minus ok 1 minus ok wjk times 1 minus oj oi. So this is the whole part of the equation. So if our output layer consists of the higher dimension instead of 1, so we need to sum up all the layers of k. So this will become k, summation of the output layer. So we have the derivation we have already derived from our model here. So this is our neural network model. By using the backpropagation algorithm, our aim is we want to determine what is the delta Wij and delta Wjk. So delta Wij will be equal to this part, and the delta Wjk will actually this particular part. So in the next part of the lecture, I will show you how we will plug in the value, and then later on how we are able to calculate the forward pass and then the back propagation of the model. What is the parameters required to calculate in order to update the weight later on. So thank you very much.